All right, this one, number 12, sounds super hard, but it's really not that bad. It says, what is the ratio of the electrostatic force to the gravitational force between two electrons? Okay, so, sounds crazy. All we're going to be doing is setting these kind of equal to each other. Not really equal to each other. We're going to set them as a ratio, so dividing by each other. However, they're going to have two of the same terms, so we can cancel out and then just plug in information and then just see what number we get, and that would be the ratio between the force of the electrostatic force on two electrons and then the gravitational force. One thing you will see is one is going to be a whole heck of a lot stronger than the other, which I guess is kind of the point of the ratio anyways. So how do we do that? So this is going to be the force between these two. So we're going to have K times, and if it's two electrons, they're going to be the same. So instead of Q1, Q2, we're just going to have Q squared, because it's two electrons, are going to have the same charge. Okay. Put an electron there. Divided by R squared. And then that divided by our gravitational force, which is going to be big G times, and if it's two electrons, we're going to have the same mass, so m squared. And then divided by our radius squared. Well, because these are going to be the same, let's divide by it. There is, I mean, you could multiply with the reciprocal and that kind of thing, but either way, we're going to get rid of them. All right? So that is going to be equal to our K constant times our value of Q squared divided by the G constant times m squared. Okay? All of this, you're going to be able to look up on our answer sheet. There are going to be some fairly big numbers, but K is going to be, as we know, 9 times 10 to the 9th. G is going to be 6.67 times 10 to the negative 11th. Okay. Our charge of an electron, yeah, there's that E. It's going to be negative, and you really don't need to do the negative, but actually you don't want to do the negative for this one, but it's there. I'm just going to put it there. 1.6 times 10 to the negative 19th, and that's in coulombs. And then our mass of an electron, mass of an electron, I was like, that would be way too big for mass of an electron. Mass of an electron, 9.11 times 10 to the negative 31 kilograms. And yeah, we're literally just putting this in. So it's going to be 9 times 10 to the 9th multiplied by, what's this? 1.6 times 10 to the negative 19th. And we're going to square that. We're going to square that. And 6.67 times 10 to the negative 11th. Multiply that by 9.11 times 10 to the negative 31st. And oh yeah, we're going to square that too. So if you do that, you should end up getting 4.14 times 10 to the 42nd. Okay? So what that means is the force, the electrostatic force between two electrons is at a certain distance, 4.14 times 10 to the 42nd times stronger than the gravitational force. Right? That is a very big number. So what's interesting, though, is even though, yeah, the gravitational force is basically negligible between two electrons, it has an infinite range, where even though this is massively stronger, you know, when the force between two electrons, it has a very short range, or very short range compared to how fast or how far gravitational force can go. The gravitational force extends, you know, the entire universe, essentially, whereas the electromagnetic force really only exerts itself when things are relatively close together. So that is number 12.